And now my favorite lecture, because manure happens. Let's do this lecture as a series of questions and answers, taking them one step at a time. And as we hit each new section, just give thought to the question before we walk through the answers. So our first question is, what factors influence how much manure is produced and its composition? And the answer is, as you would suspect, a variety of things. First is the species of animal. Obviously, cows produce more manure than chickens do. Horses produce more than ducks do. Within a species, the ration that the animal is eating has a big impact on composition, but also on quantity. Highly digestible diets equal less manure because more of what they consume is digested. Diets that are high in protein yield manure high in nitrogen. Diets high in phosphorus produces manure high in phosphorus. High fiber diets tend to produce more manure, more bulk. The age of the animal, its environment, its productivity. Larger animals produce more than smaller animals. Lactating cows produce more manure than dry cows. Obviously, the number of animals on the farm influences the quantity of manure that's produced. And then the manure handling system. Some manure systems are set up to handle extra water. Sometimes bedding is included in the manure, and these are all factors that you need to consider when you're designing your manure management system. Because there is such variation in manure composition, especially due to diet, the age of the animal, its productivity, handling, storage, and so on, most permitting systems require manure sampling on a regular basis. For instance, the Virginia Pollution Abatement Permit, which is Virginia's version of the CAFO permit, requires representative manure sampling annually. And we'll talk a little bit more about sampling and analysis later on, but one thing to watch for when the nutrient composition comes back is watch the units. If it's a solid material, the nutrients will usually be reported as pounds per ton of manure. If it's a liquid, pounds per 1,000 gallons is the normal nutrient, is the normal unit. Sometimes nutrients will be reported as percentages, so just keep an eye on that. Also, pay attention as to whether the manure analysis is giving you pounds of phosphorus or pounds of phosphate per ton. We'll talk more about that later when we get to the agronomy section. Now that you know what factors influence how much manure is produced and its composition, how do you take that and calculate how much manure storage you need? This decision, this calculation is tremendously important on any dairy farm, on any hog farm, horses, beef cattle, whatever your species. Getting the right amount of manure storage is critical. Here are some of the questions that you would ask and dig up the answers for in calculating sizing. The first is what kind of a farm you're operating. Confinement equals more manure to handle. Grazing systems, a lot of the manure is distributed, and so you're not having to store it. Animal numbers, and give that careful thought. Count all of the animals on the farm, not just one class. The species. Climatic conditions, and this can be interesting. You know that there are some areas that are arid, and so in California, let's say, in most parts of California, you are not going to have to calculate additional storage for rainfall because the net evaporation is greater than net rainfall. In our part of Virginia, here in Southwest Virginia, evaporation and rainfall on an annual basis really are about equal. And so we've got to calculate for rainfall or for precipitation at different times of the year, but on an annual basis, evaporation is similar to rainfall. Climatic conditions also influence manure storage sizing calculations. Where are you in the country? How long is your ground going to be frozen or saturated? If you're in Maine or if you're in Wisconsin or Minnesota, you've got a whole lot more time. You've got several months each year, 6 months, 7 months, 8 months each year that you really need to plan to be storing your manure, because you simply can't land apply it because the ground is frozen or saturated. Again, in areas that are warmer, that's not as necessary. For how long must you store the manure? And that's going to be driven partly by your climate, as we've talked about, but also by your permit requirements. Finally, how much wash water are you using in your production facility? And does that wash water go to the manure storage? On some farms it does, some it doesn't. On dairy farms especially, the quantity of wash water that you use is significant and influences the size of your manure storage system. So, as an example, on a dairy farm, you need to look at manure and bedding, usually. The volume that you'll need for manure storage. The first factor is the volume of manure to be produced by your animals, and then usually about half of the bedding volume, right? Because bedding will absorb manure fills in the void space. So that's the first thing you need to think about literally, is how much manure is being produced and how much bedding are you using. These things are affected by how big are your cows, how much are they eating, how much are they producing, how much feed is being wasted, how much bedding is being used, and where these will contribute to the manure handling system. And as I mentioned, parlor wash water, wastewater is a significant contributor to the volume. For instance, at the Virginia Tech Dairy, we routinely use 10, 11, 12,000 gallons of water every day for washing and other purposes. But on a net basis, we're adding 10,000 gallons a day of water to our manure handling system. So we've got to consider that when we're figuring out how big our storage pits will be. Let's talk a little bit more about water usage, because storage is expensive, and you need to give careful thought to how much water you're using and whether or not it has to go into the manure handling system. For instance, any water that crosses the production system, look there in the lower right, you've got flush water going across the pen. Obviously that water has got manure in it. That has to be accounted for. You've got to store that in your manure handling system. On the other hand, rainfall that falls on the roof of your barn, that's clean. There isn't any reason to let that go into the manure handling system. It's just going to add to the volume requirement. It's just going to cost you more because you're going to have to build a bigger manure storage tank. So pay attention to this. Control water usage. Oftentimes waters can leak and distribution lines can leak, and resulting in a lot more water going into the manure handling system than is necessary. Open feedlots and loafing lots, where's the rainfall that hits those lots? Where's it going? It's got to be handled. So is that going in your manure handling system? And then when you're setting up cooling systems, oftentimes we use water to cool cows, especially on dairy farms. And that's important, but that's water that's contributing to your manure handling system. So give it some consideration. Remember that you're going to have to pay for that storage, and concrete or tanks are expensive. The take-home message from this slide is that the quantity and composition of manure produced on a farm varies considerably, even within a species. And again, I'm using dairy as an example. And so the quantity produced is an average of about 160 pounds per lactating cow per day. That's a lot of manure. The nitrogen content, you see the variation there. The ammonia content, this is pounds per cow per day. The phosphate content of manure can vary from 0.3 pounds per day up to half a pound per day, depending on diet. Same thing with potassium. So there's a lot of variation in this, and this is one of the reasons why we've got to sample and analyze our manure on a regular basis. One last factor to consider when you're designing your manure handling system is something that you probably don't think about on a regular basis, and that is the solids content of the manure as it leaves the animal. Is the animal pooping liquid manure or a slurry or solid manure? And so this lovely table it has percent total solids on the x-axis and species on the y-axis with a little red bar indicating the average solids content of the manure as it is excreted. So now you know that chickens tend to poop drier poop than dairy cows do. Chicken manure as it leaves the animal is about 25% solids, so 75% water, whereas dairy manure is about 12 or 13% solids, so 87-88% water. Add that to the list of things that you never thought you'd know. Okay, so we've got factors that influence manure production and composition. We've talked about calculating manure storage needs. Now let's dig a little bit deeper into a couple of different types of manure handling systems. Liquid manure systems and solid manure systems. We'll start with liquid manure systems. What species use these systems? What are the components of these systems? What are the pros and the cons? Those are the sorts of questions you can expect on quizzes and the things that I expect you to know. The first thing to know is that you do have some control over there. You do have some ability to make this as a decision. You're not entirely locked into one type of system or another. And as you're making that decision, solid manure storage is usually less initial cost, right? With liquid systems, you've got a lot of pumps, and that's greater upfront cost. On the other hand, liquid manure systems are easier to automate, less daily maintenance. I will also say that if some of your manure is liquid, handling it all as a liquid avoids having two handling systems. So again, I'll take dairy as an example. By definition, we have liquid waste on a dairy farm because of the parlor wash water, which can be significant. Manure, as it comes out of the cow, you could get that dry enough to handle it as a dry. If you're adding a lot of bedding, you could handle that manure as a solid material. But then you've got to have two handling systems. So oftentimes we'll blend those waste streams and yield a liquid manure product so that we can handle it in a single system. So, liquid manure systems. These are most common on swine farms and on dairy farms. They can be highly automated, especially if there is a flush system. I'll talk more about that in a minute. We have a flush system at the Virginia Tech Dairy. It is highly automated. Solids separation may or may not be needed. So again, it is possible to divide dairy manure into a liquid fraction and a solids fraction. And depending on your situation, that might be desirable. But it'll give you two manure handling systems to manage, two distinct waste streams. Components of liquid manure handling systems. This definitely looks like a sequence of quiz questions. When you're planning a manure handling system, you've got to think about collection of manure, transfer of manure, storage of manure, and then transport of manure from the storage system out to the fields. So, under manure collection, there are different ways to collect, that is, to get the manure out of the barn. Flush systems, a slatted floor system, scraping with a tractor or with a cable, and I'll show you some pictures of each of these. How are we going to transfer the manure from the barn to the pit once we've got it out of the barn? Will the manure flow by gravity? Are you going to have to auger it? What kind of piping are you going to need? Pumps, that sort of thing. Storage is the third component of liquid manure handling system. Often this is a concrete pit. It can be an earthen basin. It can be a lagoon. And finally, how do you transport manure from the manure storage system to the field? Usually that's going to involve agitation and a tank wagon. Sometimes you might irrigate that manure out to the fields. So here's a schematic of the 4 components, and this is on a dairy farm, but the same components would be in place on a hog farm anywhere where there's a liquid waste stream. So first is collection. In this case, there's an automatic alley scraper, a mechanical scraper that is scraping the manure out of the barn. Dropping it into a gutter. There is a cross gutter cleaner and then a pump pumping, so to transfer the manure from the barn to the manure handling system. Storage, in this case, is an above ground waste storage structure. That might be concrete, or it might be one of those blue slurry stores that you'll see sometimes. At the Virginia Tech Dairy, it's a concrete above ground waste storage structure. We've actually got 3 of them, and collectively they provide us with 2.1 million gallons of manure storage. That's a lot of manure. Transport and application, shown in this graphic and pretty typically on dairy farms, will be a pump agitating, mixing up the manure, and then loading it into trucks, and trucks bringing it to the field. So collection, transfer, storage, transport, and application. Let's talk about collection or manure removal from the barn. How do we get the manure out of the barn? Here in the upper left, we have a very old style system. That would be you plus a shovel. Unfortunately, that's not required much these days. Another system that you'll still see on a lot of farms is scraping it out of the barn with a tractor. Usually there will be a scraper on the back, and a lot of times it's got like a tractor tire as scraper. So less labor intensive maybe than you plus shovel, but still fairly labor intensive. Another option that was very popular for a while on dairy farms and has faded a bit now is a slatted floor. If you look at this picture, you'll see that there's concrete flooring there, but with spaces between them, and there's a manure storage tank underneath that slatted floor. So basically, the cows work the manure down into the pit, and you don't need to remove it. The cows will do it for you. They'll just trample it down into the pit below. Engineers love this system because there's no moving parts, and it's as automated as can be because it doesn't require any intervention from you. On the other hand, farmers tend to hate it. It's not good for the cow's feet. It doesn't give them good traction. Also, these systems, if they're indoors, if they're inside of a barn, are highly odorous. You've got a lot of odor being emitted off of the 4 sides of the manure slats and then the pit down below. So frankly, slatted floor systems stink. They stink for cow health, and they stink literally. A fourth way of removing manure from barns, very common, would be these mechanical scrapers, these automated alley scrapers. And a fifth way is to flush the manure out of the barn. Usually this is with some kind of recycled gray water, but there will be flush valves in every alley, and open the valve and thousands of gallons of water come gushing out and carry the manure down the alley and into whatever the collection system is at the other end. This can be highly automated. At the Virginia Tech Dairy, we use a flush system. It is set to automatically flush 4 times a day. We can also just hit the button and manually flush if we need to. So there's a lot of positives from an automation system perspective. It's also results in nice clean alleys, and it's fine for the cow's feet. Sometimes people wonder, does it soften the cow's feet? But it's fine. The manure, the time that the cows are actually exposed to this liquid is minimal, a matter of minutes, not hours, and the clean floors are really good for their feet. There's a downside to this. You've got to size the manure handling system larger because you've got to maintain a certain volume of liquid in order to be able to recycle it and come back through to flush. So flush systems usually require larger storage than scrape systems do. Here are some common manure storage systems. Again, the above ground tank. This is at the Virginia Tech Dairy. There's a slurry store. That's a brand name. It's the same company that makes Harvest Store silos, those blue silos you see everywhere. They make manure storage systems and call them slurry stores, so you'll see them sometimes. Another very common storage system on dairy farms is a slurry pit. This looks like just a hole in the ground that we dump the manure into, but in actuality they are highly engineered, seriously. These are lined, usually a clay liner that is 12 inches. The clay is 12 inches thick and packed so tight so that there's minimal permeability. These pits might also be lined with like a plastic liner, but even these clay-lined pits, if they're properly designed, they're sealed. That manure is not going to get into the groundwater, and this is obviously lower cost than the concrete or the slurry store tanks. Okay, let's talk about solid manure handling systems. I want you to think for a minute, what species, what are the components, what are some of the positives? What are some of the negatives to solid manure handling systems? Solid or semi-solid manure handling systems are common on beef feedlots or on beef farms. You'll see this out at Virginia Tech on the other side of 460. There's this kind of a barn with some beefers with outside access to pens. That manure is handled as a solid. Some of the components that are required, you really do need to put gutters on your roof so as to divert that water, otherwise you're going to end up with a big old mess in the pens. You are going to need to have some kind of runoff collection gutter. Even though the manure accumulates mostly in the pens and you scrape that up periodically, rain will hit it and you will have some runoff. And so usually there's some kind of a runoff collection gutter, then there's some kind of a solids storage structure, and usually some kind of a waste storage pond to handle the liquid runoff. Depending on how the system is set up, you may or may not need that solid separating basin that you'll see there. So divert the clean water, collect the runoff, and then just scrape and stack the dry manure solids. Pretty low cost. Again, remember I said that solid manure handling systems usually lower cost up front than liquid manure handling systems, a little bit simpler. On broiler and turkey farms, the most common system is called in-house storage. So as the birds grow, we provide them with bedding, usually that's sawdust, and the manure and the sawdust and the bedding just accumulates in the house with the birds as they grow. Collectively, the bedding plus the manure is called poultry litter, L-I-T-T-E-R. And the barns are periodically cleaned out. Sometimes they are cleaned out with every new flock of birds. In other situations, they will accumulate, and the litter will just accumulate across 5 or 6 cycles of birds, and the barn is cleaned out once a year. So you're literally storing the manure in the house. Once you do remove it from the house, you've got to cover it. The law in Virginia is that if that stack is going to be out for more than 14 days, it must be covered so as to prevent runoff. In practice, most broiler farms, most turkey farms have a dry manure storage shed, so when they clean out, they store it in the shed until it's time for manure application. So we've seen that dry or semi-solid manure handling systems are common on beef farms. They're common on broiler and turkey farms, but you'll also see them on dairy farms. Out at the Virginia Tech dairy, we have this dry stack. We have a shed where we store dry manure, and that's because even though most of our manure is liquid, there is some dry manure that's produced. So calves are raised in hutches or pens, and usually they're heavily bedded, and so that's a solid manure system. At Virginia Tech, this dry stack storage barn actually handles all the dry manure from the Virginia Tech farm. So the horse manure goes in here, sheep, beef, as well as the solid manure from the dairy farm. So this kind of dry stack storage is pretty common on most farms. Just one more time to mention the manure handling systems on beef farms and some of the factors that you've got to consider. Think about runoff control, because most of the time we're not housing beef cattle indoors. They'll have some shelter, but most of their time and most of the manure is deposited outside. And so if you're in Virginia, if you're in the Northeast, if you're in the upper Midwest, a fair amount of rain is going to fall, and so you've got to be thinking about runoff control. On the other hand, a lot of our feedlots in the country are in more arid areas, Texas and Oklahoma. And there, yes, you still have to think about runoff control, but it's less of a concern. I'll just briefly touch on solid separation. That could be an entire lecture for itself. But on swine farms, on dairy farms, where you have a liquid manure stream usually coming out of the barn, there are some situations where it might be to your benefit to separate the solid fraction from the liquid fraction. For instance, this would allow irrigation with the liquids. If you think about or go look at the dairy manure in the manure tanks at the Virginia Tech dairy, even though we flush and so it's a pretty liquid material, you couldn't irrigate with that. The lines would get clogged real quick. But irrigation can be a really effective way of distributing nutrients, and if you want to do that, you really need to be thinking about solid separation. On hog farms, you often or usually will do some solid separation because the liquid is going to be treated in treatment lagoons, either by aeration or by anaerobic means, and the more organic matter you can pull out before that, the quicker and easier that treatment is going to be. Also, that solid that is separated can be a useful byproduct. Some farms use manure solids for bedding. In the old days, not so much anymore, manure solids, this is gross, but there's still nutrients in there. And so the manure solids from one species might be fed to another. So classic for a while was poultry litter being fed to beef cattle. There's kind of an ick factor with that, but there are also some biosecurity and pathogen issues that have pretty much eliminated that practice. Those manure solids can also be composted. Maybe you've got a market for that. And one positive to separating, if you've got kind of a slurry, kind of a thick liquid coming out, whether it's a dairy farm or a hog farm, a slurry is kind of hard to handle. You know, it's halfway between a liquid and a solid. It is actually a lot easier in some ways to handle liquids as liquids and solids as solids. The slurry is sort of an awkward in between. It's awkward to pump. It's awkward to spread on the fields. And so there can be some benefits to solid separation. On the other hand, and our dairy farm crew will tell you this, a manure separator can be a major headache. It's a piece of equipment to maintain. Farmers typically don't enjoy maintaining equipment. You see a screen separator here on the right. Any of these mechanical separators can be a maintenance nightmare. Okay, so we have removed the manure from the barn. We have transported the manure to our manure storage. We have stored the manure. And now it's time to land apply it. Here are some things to think about with land application. The first is you're using this manure as fertilizer. So your goal is a nice even application. Your goal is to apply it at a time when the crop can use it. Spreading manure on frozen or saturated ground is a bad idea for multiple reasons. Very high likelihood of runoff. There's no crop growing when the ground is frozen. There's no crop growing, and so you're going to lose a lot of the nitrogen in the manure before the crop can use it. So in many states, it's actually illegal to spread manure on frozen or saturated grounds. In every state, it is not recommended, and that drives our manure storage decisions. We typically want to have enough manure storage to get us through the season where the ground is frozen or saturated. When land applying, one management practice that many farmers use if they're able to is manure injection. So literally shooting the manure under the surface of the soil. That prevents nitrogen loss, maximizes the fertilizer value of the manure. It also reduces odor emission. Incorporation is spreading it and then coming along behind with some kind of a tiller and plowing the manure into the soil, and some states are requiring either injection or incorporation of manure within 24 or 48 hours. They do that for odor reasons usually, to limit odor emission. A fourth critical factor, and we'll spend a lot of time on this in a couple of weeks, is the timing of manure application relative to crop needs. Again, there isn't a crop in the world that needs manure in December in the northern hemisphere. Springtime, when you're planting the crop, fall, Summertime, you've got some you've got some counterbalancing factors at play there. On the one hand, the crop is growing rapidly and needs the nutrients. On the other hand, if the crop is growing in the field, it can be real difficult to land apply manure. Irrigation systems, of course, you can apply manure while the crop is growing. So these are considerations that we'll spend a lot of time talking about, is the timing of manure application to maximize fertilizer value. When it's time to apply the manure, agitation is a best management practice on dairy farms with their liquid manure handling system. This is not usually a best management practice on hog farms. Hog farms do have liquid manure handling systems, but usually they're designed to accumulate sludge slowly over a period of years, let the solids settle to the bottom of the pit and accumulate, and then just pump off the liquids on top. But on dairy farms, we've got a lot more solids in the manure, and so we typically just store it as a slurry. Come time to land apply it, we've got to agitate it, we've got to mix it up. Otherwise, we've basically got water on top and sludge on the bottom, so we agitate. And then surface apply. On the upper right is a box spreader, lower right is kind of a standard manure application truck. Here's some more photos of equipment or concepts. I talked about manure injection so as to maximize the fertilizer value and reduce odor emission and ammonia emission, and so the upper left is a picture of that. You've got the honey wagon or manure tanker truck, then the pipe going, and if you look just in front of those tires, you've actually got nozzles injecting the manure down into the soil. Lower left is irrigation system. On the right is an aerial photo to remind you that you want a nice even manure distribution pattern. This guy is not doing a particularly good job, right? Everywhere that it's dark, there's a lot of manure and a lot of nutrients. Great, but you're trying to grow corn across that whole field, and the corn's not going to grow real well where there is no manure been applied. So you got to pay attention to your application pattern. It matters more than you'd think. Okay, so we've got a lot of information on manure quantity and composition. Manure sampling. There is a whole science to sampling manure. It's amazing some of the things that we do research on. So sampling with a liquid, you're usually looking at a cup on the end of a stick, and you're collecting multiple samples from multiple locations within your pit or your tank. You are pooling them in a 5-gallon bucket and then subsampling. With solid manure, you're collecting samples with a shovel from multiple locations within the pile, then again pooling them, mixing, and subsampling. It's really important to get a representative sample or you've got bad data. Think about this for a minute. Do you sample and send off for analysis before you do your manure application or during manure application? You probably think before, because you need the data when you go to land apply the manure. But the problem is with liquid manure on dairy farms, at least, usually you're agitating in the morning and spreading that afternoon and the following days. So you need to agitate in order to get a good sample of the manure. So usually you're agitating and then you're spreading. And so you're really not going to get that data back in time to drive your manure application. That's okay. Typically what we do is we'll sample and analyze twice a year, in the spring and in the fall. And if I'm land applying here in the springtime, I'm sampling now, but the data I'm using for my manure application is last year's sample from the springtime. That's not a perfect practice, because certainly it can vary a bit year to year if I've made dramatic changes in my diet or my management system, but oftentimes it's as good as we can do, because the turnaround time on manure analysis is not fast. It's at least a week, if not more than that. How to submit, where to submit. How to submit. Nalgene bottles, Ziploc baggies, where to submit. Every county has a government agency center, the Farm Services Agency. Usually there are several offices in that same building. The NRCS, it's usually where you go for your cost share, for your permit paperwork, and often the extension office is located there also. But you go to your local Farm Services Agency and drop off the sample, and they'll ship it. In many cases, the analysis is paid for by the state. Alternatively, you take the sample, you freeze the sample, and you ship the sample. And usually the state will provide you with appropriate sample containers and shipping materials. When the analysis comes back, remember to watch your units. What did I say the units would be if it was a solid manure? So my phosphorus content of the solid manure is going to be expressed how? It might be expressed as a percentage, but usually it's going to be expressed pounds per ton. If it's a liquid manure, usually the units will be pounds per 1,000 gallons. This, just to reiterate, with liquid waste, the best time to sample is just before land application, but agitation is critical to get an even representative sample. So if you are in a situation that you can agitate sample and then wait a week for the results to come back, super. Most times farmers just kind of want to get in and get it done. And continuous agitation is needed, especially for a good phosphorus analysis. For nitrogen and potassium, there's a kind of a sample where it's like a pipe, and you can do a vertical column, a vertical profile, and get a representative sample that way, but phosphorus, you'll get lousy numbers. On hog farms with their treatment lagoons, you want to sample a vertical profile, and as I said, on hog farms, usually what they're trying to do is land apply the liquids and let the sludge accumulate. And they'll let the sludge accumulate for 15, 20 years sometimes, until the unit is closed or until so much sludge accumulates that it's interfering with storage volume. So usually what you'll do, you won't agitate hog manure, but you'll sample to get a column, a vertical profile. Solids and semi-solids. Get a lot of samples, composite it, mix it well. Shipping your samples. Your options are drive and drop them off, ship them immediately, or freeze them if they can't be shipped immediately. Some of the details that are here are useful to make sure that your samples stay intact. For liquids, especially if you're going to freeze it, well, even if you're not going to freeze it, don't fill the bottle all the way. Very likely to burst as either as you freeze the material, it'll expand and burst. Certainly if it heats at all, you're going to end up with a big old mess on your hand. Here are those units of analysis, just so you can see them. Pounds per ton, pounds per 1,000 gallons. There are tables that we will use in class estimating manure production, and oftentimes they are expressed pounds per 1,000 pounds of live weight, maybe cubic feet per day per 1,000 pounds of live weight. A little factoid to file away, the density or the specific gravity of manure is very close to water. File that under facts you never thought you'd know. All right, something you hope never ever happens to you. You finish chores in the morning, you go into the house to have a sandwich for lunchtime, and you come out and your manure tank is empty. That's a holy feces moment. And it happens sometimes, and it happens to good farmers. You can have just kind of catastrophic failure of the manure handling system, or, and this would go back on the farmer, maybe you've got an overflow because you don't have adequate storage. Rarely happens, you hope it never happens. So what do? If it happens, stop the flow. If it's a busted valve, if a valve was left open, close it. Do whatever you can to stop the flow. Apply absorbent materials along ditches and around basins. So bales of straw, build berms with dirt. dig temporary basins, dig diversion ditches, do whatever you can to keep that manure from getting to the stream, from getting to the wetland. So stop the flow, try to soak it up, divert it so it doesn't get to the stream, and then you get your butt back in the house and you start calling, you get on the phone and start calling the agencies. If you've got a permit, you call your permitting agency. If you've got a nutrient management plan, you call your nutrient management planner. If your farm is upstream from a drinking water treatment system, you call the drinking water treatment system. Don't try to hide it. It's like anything. The cover-up is always causes more problems than the actual event itself. All right, getting down to the end now. You've got a field and you've got a manure. Now, step by step, how are you going to calculate how much manure to apply to that field? I'm going to just walk you through on one slide. This is something we'll spend a couple of classes on, but I just want to put it in one place where you can come back and reference it. Calculating manure application to meet crop needs. Okay, so we're using the manure as fertilizer. We want the manure to supply what the crop needs. So the first thing you've got to figure out is, what does your crop need? That depends on the type of crop. It depends on yield. Heavy yielding corn silage requires more nutrients than low yielding fields for corn silage. Corn requires more nitrogen than alfalfa, right? Because alfalfa can fix its own nitrogen. So you got to figure out what the crop needs. And there are all sorts of tabular values, table values, that are pretty accurate for the nitrogen, phosphorus, and potassium requirements of different crops. Once you know what the crop needs, now what does the manure contain? And this is where your soil test, your manure test rather, comes into play. Sample the manure, test it for nitrogen, phosphorus, and potassium. You are going to need to think about adjusting for nitrogen loss during application. We'll spend a lot of time on this, but if you surface apply and just leave it there, very little of that nitrogen is actually going to be available for the plant's needs. So, what does your crop need? What does the manure contain? And then here's the magic formula. Go ahead and write this down 58 different places. The need divided by the content equals the application rate. So we'll calculate need, pounds of phosphorus per acre. What's the manure phosphorus content? Pounds of phosphorus per ton. You divide pounds per acre by pounds per ton. You get an application rate of tons per acre. You take the crop need, divide by the manure nutrient content, and get the manure application rate. Write this out a couple of times to convince yourself that it's true. I'll do corn. Corn needs 150 pounds of nitrogen per acre, for instance. And I've got a liquid manure, and that liquid manure has 20 pounds of nitrogen per 1,000 gallons. I take pounds per acre of need divided by pounds per 1,000 gallons manure content, and I'm going to get application rate, thousands of gallons per acre. We'll spend a lot of time on this, but I did want to get it for you in one slide so you can refer back to it. To summarize, manure happens. There are several considerations in designing and planning and managing your manure handling system. The type of animal that you've got, how are you going to collect and transport and store the manure? On some farms, maybe there's a desire to treat the manure separation that we talked about, or on hog farms, they'll design a system specifically to reduce its nitrogen content. Nutrient conservation or loss characteristics, so after I land apply it, am I going to lose a lot of nitrogen? If so, I just need to account for that. And then land application and nutrient utilization by the crops. So it starts with the animal, goes all the way through to meeting the crop needs.